Let's start MOT. It is molecular orbital theory. Well, it's very important. Well, with the help of MOT, we can discuss a few and very important things like number one, it's bond order. The next one, that is existence of the molecule, and the third one, which is called the magnetic property of the molecule, and the fourth one, which is called the electronic configuration of molecule. Well, let's see that how MOT diagram will form when we consider hydrogen. Well, in case of hydrogen, what you have to do, you have to introduce one hydrogen at the left hand side and one hydrogen at the right hand side. Mention the atomic number, and now the electronic configuration, that is 1s1, and of course 1s1 for this hydrogen as well. So we can understand that in s orbital there is a single electron, and at the right hand side we have one more hydrogen, and whose 1s orbital consisting one electron as well. So these are the atomic orbitals. Whenever they combine, they will create two energy levels. Well, let's see that when these atomic orbitals are combined, they will create the low energy level, which has been called bonding molecular orbital, and we can suggest the name of it. It's sigma 1s. Then at the upper energy level we get the anti-bonding molecular orbital, which can be represented by the star sign here, and we can name this molecular orbital, that will be sigma star 1s. Alright, now let's see that. So we have the bonding molecular orbitals, and such you can say orbitals are formed when the addition takes place between two atomic orbitals. And of course this anti-bonding molecular orbital is obtained whenever the subtraction is going on between the two atomic orbitals. Alright, now we can fill the electrons one by one with the help of Hund's tool of maximum multiplicity. Well, let's see that how. So here we have the first electron, so you have to introduce this electron in this lower energy level. Then you see that the next electron, which is at right hand side, this electron also filled in this sigma 1s orbital. So there is no other, you can say, electron in 1s orbital. So overall this is the MOT diagram of hydrogen. Now we can see that what will be the bond order. So the bond order, which has been called 1 by 2, it's NB minus NA. This is the formula. So we can go for 1 by 2 here. number of electrons in bonding molecular orbital, that is Nb. So here we have the 2 electrons in bonding molecular orbitals. We can place 2 here, minus anti-bonding molecular orbital contains how many electrons? Let's see. There is nothing. That means it's 0. So the bond order comes, it's 1. So do you think that this molecule is existing? Yes, it is. It is existing molecule. Because the bond order, if the bond order comes 0, then there is no existence of the molecule. But it comes in whatever it is, it's 1.5 or 1 or 2 or whatever, then the bond will definitely exist, or molecule will be exist. All right, let's see that how the magnetic character we can decide. So we can decide the magnetic character by this formula, mu equal to root, it's n plus 2. This is the formula. Now you see that where the number of unpaired electrons, so you see that 2 electrons are both are paired now, and in this one there is no electron. That means there is no unpaired electron. So n value that comes 0. Obviously this mu value is obviously 0. That means the molecule must be diamagnetic. Alright, it doesn't have any kind of magnetic character, so this will be the diamagnetic one. And in last we can go for the electronic configuration. Let's see that what is the electronic configuration. Here is the electronic configuration. So electronic configuration is, you see that sigma 1s, it consisting 2 electrons. So you can write here sigma 1s 2. But when we talk about the sigma star 1s, so sigma star 1s, there is no electron, so you have to write 0. So this is the electronic configuration of hydrogen molecule. Well, let's see that how the H2 plus will form. That means the MOT diagram of H2 plus. Here we have the one hydrogen whose number is 1, and there is one more hydrogen whose number is 1, but it doesn't have 1 electron. So basically we have to place the positive charge here. Alright, this become what? H2 plus. If we talk about the H2 plus plus, then the plus charge has to be there at that particular hydrogen as well. Okay, so this is H and this is H plus. Let's see that what is the configuration here. Here we have the 1s1 and it is 1s not, because no electron is there, because it is carrying actually positive charge. So one box is located, this is the atomic orbital, and here we have one more atomic orbital. One electron is there. Now by addition you can simply go for this sigma 1s, and at the upper hand side we have the anti-bonding molecular orbital, which can be written like this, sigma star 1s. Let's fill the electrons. So we have the only one electron, so you have to fill the electron in sigma 1s. So this is the complete, you can say, MOT diagram of H2 plus. So what will be the bond order here? The bond order, that will be 1 by 2. It's Nb minus Na. So it's 1 by 2. What is Nb? So number 1 electron is here. So 1 minus Na, number of electron in anti-bonding, there is nothing. So obviously it will be 0.5. So do you think that this molecule can exist? or this species can exist? Yes, it is, right? Well, let's see about the magnetic property. So mu, that will be equal to root it's n plus 2. Here we have the n value, that comes 1, because we have one unpaired electron in the sigma 1s. So n value, that comes 1. So mu equal to root, it's 1 plus 2, that comes root 3. So root value comes whatever the, it's 1.7 or something. Okay, this will be paramagnetic. It is paramagnetic. Now we have the electronic configuration. So let's see that what is the electronic configuration. So sigma 1 is one electron is here, and at the upper end side sigma 1 is not. This is the electronic configuration. Now you can try these species. You can make the MOT diagram and of course their existence and magnetic properties. Well, let's see that how the boron and carbon and nitrogen MOT diagram can be prepared. Well, let's see that. It's B2, C2 and N2.